Hi, this is Dr. Hayek and this video is about electrochemistry, and today we will talk about electrolysis, electrolytic cell, and electroplating. This is going to be the last video on the series of electrochemistry, so please check my previous videos. I will post the links in the description below. A galvanic cell produces current when oxidation-reduction reaction proceeds spontaneously. A similar apparatus, which is called electrolytic cell, uses electrical energy to produce chemical change. The process of electrolysis involves forcing electrons into a cell to produce a chemical change for which the cell potential is negative, which will cause a non-spontaneous reaction to occur. Consider the following reaction between zinc and copper. The cell potential is 1.10 volt, which is positive. So this redox reaction will proceed spontaneously in the forward direction, and therefore it will form a galvanic cell. If we were to force this reaction to proceed in the reverse direction, we have to apply a potential which is greater than 1.10. The power source with a voltage greater than 1.10 will force the electrons to flow in the opposite direction. Notice that since the flow of electrons is opposite in the two cells, the anode and the cathode are reversed as well. Also, the flow of ions in the salt bridge will be reversed as well. Electrolysis has great practical importance. For example, charging a battery, producing metals from their ores, or plating an object, which is the example that we will see next. Consider the following electrolytic cell where a ring is being plated with copper atoms. Now, the copper electrode represents the anode where the oxidation is happening, and the ring represents the cathode where the reduction is happening. Both they are immersed in a copper 2 solution. As you can see in here, copper ions are being generated from the anode and they are being reduced at the cathode, which means plated on the surface of the ring. The copper electrode will decrease in mass with time and the ring will increase in mass with time. Now we will consider the stoichiometry of electrolytic processes. The question is, how much chemical change occurs with the flow of a given current for a specific time? Now suppose we want to measure the mass of copper that was deposited on that ring. We know that at the cathode, the copper is getting reduced, and therefore we have a reduction half equation. We can calculate the amount of charge by multiplying the current intensity, which is in ampere, by the time, which is in second. We know previously that the amount of charge is equal to number of mole electrons multiplied by Faraday's constant, where Faraday's constant is equal to 96,485 coulombs per mole electrons. So from the amount of charge, we can calculate the number of mole electrons. From the half equation that's happening at the cathode, we can determine the number of mole of metal that's being plated on the ring by using the molar ratio between the metal and the electrons. From this expression, we can calculate the number of mole of metal that was deposited on the ring. Using the number of mole and the atomic mass of the metal, we can calculate the mass of metal that was deposited on the ring. So let's review this. If we have current and time, we can calculate the amount of charge applied. From the amount of charge applied, which is in coulombs, we can determine the mole of electrons that passed through the cell. From the number of mole of electrons, we can determine the number of mole of copper. And you all know from the number of mole of copper, by multiplying it by the molar mass, we can determine the grams of copper that was plated on the ring. Let's take another example of electrolytic cell, which is hydrolysis or electrolysis of water. We know that hydrogen and oxygen will combine spontaneously to form water. The free energy released can be used in a fuel cell to produce electricity. As you can see from the two half equations, the cell potential of the redox reaction using water is going to be negative. When a potential greater than 2.06 volts is applied to water containing enough ions for a current to flow, an immediate evolution of bubbles of hydrogen and oxygen will be observed. Note that twice as much hydrogen is produced as oxygen. I hope this video was helpful to you, so please like, share, and subscribe, and I will see you next time.